This is section 20.2, which is balancing chemical equations. And while it is real life chemistry, as you can see from the pictures, everything we do has formulas in math. We're going to be looking at what happens when we have a manganese ion and a chromate ion, and essentially how they're going to undergo a redox reaction and how to write that chemical equation. So here are the examples we're going to do. I had to break this into two pieces because the original video was just too long. So this first video has the tin and the iron. It has these two examples with the rules. The other video, part B, has the harder ones. So please take your time with the easy ones before moving on to the hard ones. Easy, why do I say that? Well, we have tin 2 plus and we have iron 3 plus, and they're going to form tin 4 plus and iron 2 plus. You could waste a lot of time putting coefficients in front and balancing, but this section teaches you how to do it with some very nice rules. I will break them into what are called two half reactions. The tin 2 plus to the tin 4 plus, the iron 3 plus going to form the iron 2 plus. Based on what we learned in section 20.1, what we really want to do is balance the elements. They already are. Now what we want to do is balance the charge. So if I add 2 electrons to the top equation, that makes this an oxidation, and we have a balanced equation. Plus 2 on one side, plus 4 minus 2 on the other. If I look at the iron, I have a plus 3 and a plus 2. In order to balance that, I will have to add an electron, and that is called a reduction. And what we have on one side is a plus 2, and on the other side a plus 2. Then what you will do is add these two equations together, these two half reactions. Notice we already have 2 electrons here. We only have 1 electron on the reduction process, so we need to multiply that by 2. We'll be doing a lot more examples, but if you're stuck here, take a little bit of time. So what we have overall is Sn2 plus 2Fe3 plus going to form Sn4 plus and 2Fe2 pluses. So again, this is our simplest example. When we say mass balance, we want the same number of elements on each side. We have 1 tin and 2 irons on each side. When we say charge balance, like that's kind of tricky. So overall, it's the same charge on each side of the equation. And when we multiply the iron by 2, we had 2 for tin and 2 for iron. And the number of electrons lost must equal the number of electrons gained. So I have a plus 2 and a 2 times a plus 3. Plus 2 plus 6 is a plus 8. That's on my reactant side. On my product side, I have a plus 4 and a 2 times a plus 2. So it's a plus 4 and a plus 4, which is a plus 8. Now, some of you have talked to me and you learned a different way to do it in high school. So you're on your own, I guess. If you're a strong student, usually it always works out. But if you haven't always gotten things right, what we have next is a process. So if you can't do it by inspection, what are the rules? This looks quite cryptic at the moment. I'm putting little numbers over each and every one of the steps. We will do the exact same thing here. We will take the iodine and put that on one side. We will take the S2O3 2 minus and the S4O6 2 minus, and we'll put it on the other side. We're breaking it down into two half reactions. Rule 1 says balance the number of atoms. Well, I have 2 in a iodine molecule. That means I need to put a number 2 in front of the iodide ion, so I've balanced those 2 elements. The second step says balance the oxygens. We have no oxygen. The third step says balance the hydrogens. We have no hydrogen. And so essentially it takes us to step 4, which says balance the number of electrons. For us to have the same charge on each side, we have to say 2 electrons plus iodine makes 2 iodide molecules. And I guess anions. I am not going to put the phases in. It just gets too crowded. So this reaction right here, this is our reduction process. It should be matched by an oxidation process, so let's get started. If I look at S2O3 and S4O6, I need to put a 2 in front of the S2O3, so now I have 4 sulfurs on each side. I have oxygen, but notice I have 2 times 3. I have 6 oxygens, and on the other side I have 6 oxygens. So I don't have to do anything there. And I have no hydrogen at all. So essentially, I need to now balance the charge. And I have a -4 on the reactant side and a -2 on the product side. So my balanced half reaction will be 2 SO3 2 minuses goes to form S4O6 2 minus plus 2 electrons. What I have now is a -4 and a 2 and a -2 and a -4. So this is my reduction process. What I want to do now is double check. My number of electrons reduction equals my number of electrons oxidation. There's 2 on each side. The next thing I want to do is add the equations together.